In this video, I want to talk about finding the midpoint between two complex numbers in the complex plane. So this is going to be pretty much like finding the midpoint between two ordered pairs in the real number plane when you have the x-axis and the y-axis. So if you recall from geometry, we have two ordered pairs here, x1, y1, and x2, y2, and their midpoint is going to be found by taking the average of the x's and the average of the y's. So we add them up, divide by 2. Okay, so let's do 3 examples with complex numbers. And first, let's go ahead and look at a common relationship here. We have two complex conjugates. We have -5 plus 3i and -5 minus 3i. And let's go ahead and look at this relationship, what happens. So the midpoint for complex numbers, and we can write each of these is a plus bi and c plus di. So this midpoint, or the number that's going to be right in the middle of these, is going to be the average of the real parts plus the average of the imaginary parts. And again, you can kind of see the similarities right there. So -5 and -5 for our real parts, divide that by 2, plus, and then our imaginary parts will be 3i plus a -3i over 2. So -5 and -5 is -10 over 2. And then, of course, that's 0 over 2. So it looks like the imaginary part just goes away. And then we have -5 for the real part. So the midpoint between these two complex numbers, -5 plus 3i and -5 minus 3i, is just -5. So the midpoint will always land right on the real number axis, and it's because our imaginary numbers here ended up canceling out when we added them together. So that's kind of the special relationship that exists when you're finding the midpoint between two complex conjugates. In this second example, let's go ahead and look at the two complex numbers 7 minus 2i and 1 plus 9i. And once again, we're going to take the average of their real parts and the average of their imaginary parts, and that's going to go ahead and give us our midpoint. So the real parts, 7 plus 1 divided by 2, and then plus, we've got a -2i and a positive 9i, and we'll divide that by 2 as well. So 7 plus 1 is 8, so 8 divided by 2. And for our imaginary parts, -2i plus 9i is 7i over 2. And that can simplify nicely. 8 divided by 2 is 4. And 7i over 2, well, 7's odd and 2 is even, so 7 and 2 don't have any common factors that can divide out. But we do need to still write this in a plus bi form, so we're going to keep it 7 halves, and the I comes afterwards. So a plus bi. And this complex number will be the midpoint for these two complex numbers in the complex plane. And for our third and final example, we have these two complex numbers, 15 radical 2 plus 8i, and -3 radical 2 minus 10i. And once again is the average of the real parts and the average of the imaginary parts. So that'll be 15 radical 2 minus 3 radical 2 all over 2. And then we have 8i minus 10i all over 2. Okay, well, these are like radical terms, so they're both radical 2's. So 15 minus 3 is 12 radical 2 divided by 2, so that'll come out nicely. And here the imaginary parts, 8i minus 10i is -2i over 2, and that'll come out pretty nicely as well. So the 12 divided by 2 will be 6 radical 2, and the 2's cancel here, so I have minus I. So 6 radical 2 minus I will be the midpoint for these two complex numbers if they're graphed in the complex plane.